Hi friends, I am Amalka Santosh. I here to take the topic about DevOps. Here we cover the topic about what is DevOps, why DevOps, addressing delivery challenges, Agile and DevOps, how it is connected, DevOps versus release management, DevOps tools, and when to adopt and when not to adopt. First of all, we cover what is DevOps. DevOps is a software development methodology that combines software development with information technology operations. The goal of DevOps is to shorten the system development lifecycle while also delivering features, fixes, and updates frequently in close alignment with business objectives, thereby enable rapid revolution of product or services and reduce risk, improve quality across portfolio, and reduce cost. DevOps helps to increase an organization's speed to deliver applications and services. It allows organizations to serve their customers better and compete more strongly in the market. In simple words, DevOps can be defined as an alignment of development and IT operations with better communication and collaboration. The term DevOps is a combination of two words, namely development and operations. DevOps is a practice that allows a single team to manage the entire application development lifecycle, that is, development, testing, deployment, operations. The aim of DevOps is to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. DevOps is a software development approach through which superior quality software can be developed quickly and with more reliability. It consists of various stages such as continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. Here we can see the principles of DevOps. In shortened, the main principles of DevOps are automation, continuous delivery, and fast reaction to feedback. Culture represented by human communication, technical processes, and tools. Automation of processes, measurement of KPIs, sharing feedback, best practices, and knowledge. Development and test in an environment similar to production and to deploy multiple frequently, validate operational quality continuously. Adhere, Adherence to these principles is achieved through a number of DevOps practices that include continuous delivery, frequent deployment, automation, QA, automation, validating ideas as early as possible, and in team collaboration. Now we can see why DevOps are used. Now we cover the topic why DevOps are used. Here the top 5 reasons why the industry has been so quickly to adopt DevOps principles. First one, shorter development cycles and faster innovation. When development and operation teams are in the separate silos, it's usually difficult to tell if an application is ready for operation. Teams when development teams simply turn over an application, the operation cycle time are extended needlessly. With a combined development and operations team applications are ready to use much more quickly. This is important since companies succeeded based on their ability to innovate faster than their competitors do. Second one, reduce the deployment failures, rollback, and time to recover. As a part of the recent times experience, deployment failures is due to programming defects. The shorter development cycles with the DevOps promote more frequent code releases. This in turn makes it easier to spot code defects. Therefore, teams can reduce the number of develop, deployment failures using agile programming principles that call for collaboration and modular programming. Rollbacks are simply easier to manage because when easily some modules are affected, time to recover is an important issue because some failure has to be expected, but recovery is much faster when the development and operation teams have been working together, exchanging ideas and counting for both teams' challenges during deployment. The third one is improved communication and collaboration. DevOps improves the software development culture. Combined teams Combined teams are happier and more productive. The culture becomes focused on performance rather than individual goals. When the team trusts each other, they can experiment and innovate more efficiently. The team can focus on getting the product to market or into production, and their KPI should be structured accordingly. It's no longer a matter of turning over the application to operations and waiting to see what happens. Operations does not need to wait for the different team to troubleshoot and fix a problem. The process becomes increasingly seamless as well as individuals work towards a common goal. The fourth one is increased efficiencies. Increased efficiencies help to speed the development process and make it less prone to error. There are ways to automate DevOps tasks. Continuous integration services automate the process of testing code, reducing the amount of manual work requirement. This means that software engineers can focus on completing tasks that can be automated. The fifth one is reduced cost and IT headcount. All of the DevOps benefits translate to reduce overall cost and IT headcount requirement. According to Kevin Murphy from Red Hat, development team require 35% less IT staff and 30% lower IT cost. The industry has spoken and it's implemented DevOps at a rapid rate. Organizations are eager to take advantage of faster application delivery, enhanced innovation, more stable operating environment, and performance-focused employee teams. Here we can see the delivery challenges, customized requirement test, and DevOps and operation teams business services. In between dev and test teams and operation teams, there is a gap. We can see we can cover why there is a gap. Why gaps? Mostly delivers features after testing in deployment systems. Dev system may not be same as production system. Developers will have faster turnaround time WRT features, not as much concerned about the infrastructure as well as deployment impact because of the code changes. And also the point worries about more about PSR rewarded mainly for update lesser Turnaround time for WRT feature deployment and testing due to large number of dev builds coming their ability. Very much concerned about the infrastructure as well as the deployment impact because of the code changes. Dev and Ops. Developers work with ops to understand the impact of the code changes. Developers now work more closely with production equivalent system. Developers focuses on metrics requirement by ops team like PSR. Ops now have more clarity infrastructure need more automation on deployment. Closely monitors the dev test pipeline for each deployment with immediate feedback and better collaboration and communication. Now we cover the topic about addressing delivery challenges. Here, the top three delivery challenges: release management, release or deploy coordination, deploy, and the third one is the deploy automation. First one, the release management. The release management has been a core process of software development for decades. The purpose of release management process is to coordinate the development, operations, and deployment of software while ensuring alignment with business priorities. In enterprise release management, these processes are built around multiple key goals: managing risks, coordinating IT resources, ensuring compliance and auditing process, overseeing the cutover to new versions, maintaining alignment of the business with the development software, the business with the software development. Then the second one, the development deployment coordination or the release coordinator. A release coordinator typically is responsible for owning the planning and coordination of all phases and activities involved in the release of a system or system update into production environment. Their role facilitate release meeting and develop the release recommendations and release deployment plan based on input from multiple stakeholders within various portfolio teams. A release coordinator confirms the release deployment plan is followed and that all release deliveries, usually in the form of release activities or entry exit criterion, have been completed in line with the release dates and deadlines. Typically, we have expected to see release notes, approvals, communication, contact list, and pre and post release verification activities also managed by the release coordinator. And the third one is deployment automation. The deployment automation is what enables you to deploy your software to test and production environment with the push of button. Automation is essential to reduce the risk of production deployment. It's also essential for providing fast feedback on the quality of your software by allowing teams to do comprehensive testing as soon as possible after changes. Now, Agile and DevOps. Agile methodology involves continuous iteration of development and testing in the SDLC processes. The software deployment method embraces on iterative, incremental, and evolutionary development. Agile development processes breaks the product into smaller pieces and integrates them for final testing. It can be implemented in many ways, including Scrum, Kanban, Scrum, XP, etc. Agile versus DevOps. The key differences are DevOps is a practice of bringing development and operation teams together, whereas Agile is an iterative approach that focuses on collaboration, customer feedback, and small rapid release. DevOps focuses on constant testing and delivery, while the Agile process focuses on constant changes. DevOps requires relatively a large team, while Agile requires a small team. DevOps DevOps leverages both shift left and right principles. On the other hand, Agile leverages shift left principle. The target area of Agile is software development, whereas the target area of DevOps is to give end-to-end business solution and fast delivery. DevOps focuses more on operation and business readiness, whereas Agile focuses on functionality and non-functional function readiness. Agile development addresses the gap between customer requirement and dev plus testing teams, cross-functions teams to define development and test features, stores priorities by the PO customer, and focuses more on functional and non-functional releases. DevOps addresses the gap between dev plus testing and ops, automated release management, and focuses on functional and non-functional plus operational and business readiness, intensifies reusability and automation. Now we can see the agile plus traditional release management. Traditionally, what happens is the software developers write code for weeks and months and hands over the code to a QA team for testing, which then hands over the final release to operation teams for development. This is lack of collaboration between all these three phases: development, testing, and deployment. Developers write the code and hands over to the deployment team. Now it's up to deployment team to fix the problems and that arise during deployment of code and hands over the code altogether back to the development team to fix the bugs. All this results in a flowing of software development processes. But under the umbrella of DevOps model, these three teams are no longer isolated for each other. Most of the times, these three teams are merged into a single team where the engineers work across the entire application lifecycle from development and test to deployment to operation and deployment, a large skill that not limited to a single function. Security team may also become more tightly integrated with development and operations and throughout the application lifecycle. DevOps engineer is not a new thing. It's a set of engineers like system engineer, built automation engineer, software engineer, Linux engineer, and so on. However, DevOps engineer nature of work varies from organization to organization. In some cases, its role is automation of infrastructure and maintaining it, while some organizations span their role to the entire delivery chain. Here we can see the continuous integration extended as continuous delivery. Now we cover the continuous integration and continuous delivery in terms of DevOps. Developers practicing continuous integration merge their changes back to the main branch as often as possible. The developers changes the validating by creating a build and running automated tests against the build. By doing so, you avoid the integration hell that usually happens when people wait for leaf day to merge their changes into leaf branch. Continuous integration puts a great emphasis on testing automation to check that the application is not broken whenever new commits are integrated into the main branch. In case of continuous delivery is an extension of continuous integration to make sure that you can release new changes to your customer quickly in a suitable way. This means that on top of having automated your testing, you also have automated your release the process and you can deploy your application at any point of timing by clicking on the button. In theory, with a continuous delivery, you can decide to release daily, weekly, fortnightly, or whatever suits your business requirement. However, if you truly want to get the benefits of continuous delivery, you should deploy to production as early as possible to make sure that you release small batches that are easily to troubleshoot in case of the problem. Now we can see some DevOps tools. The main reason to implement DevOps is to improve the delivery pipeline and integration processes by automating these activities. As the result, the product gets a shorter time to market. To achieve this automated release pipeline, the team must acquire specific tool instead of building them from scratch. Currently, extending DevOps tools cover almost all the stages of continuous delivery, starting from continuous integration environment and ending with the conda- containerization and deployment. While today some of the processes are still automated with the custom scripts, mostly DevOps engineers are use various open source products. Let's have a look at most popular ones. The first one is Jenkins. Jenkins is a tool to use either a server for continuous integration or continuous delivery hub that comes with a lot of additional plugins to continuous delivery workflow. The second one is Selenium. Selenium is an automated browser that allows QA teams to write scripts and test web products. It compatible with 8 popular programming languages. The third one is Git. Git is a version control system with a repository for source code management that enables working online and offline. The third one is Chef is a tool for infrastructure as code management that runs both on cloud and hardware servers. Another popular tool in this category is Ansible that automates configuration management, cloud provisioning, and application deployment. The second last one is Docker. Docker is an instrument that helps with the packing code into self-contained units, that is containers. The last one is Nagios. Nagios is a infrastructure monitoring tool that present presents analytics in version reports. Now we cover when to adopt and when not to adopt the DevOps. When to adopt. It is adopt for e-commerce and other website projects like Amazon, Flickr, Groupon, etc. and also in cloud platforms. It is not adopt in case of mission critical applications like bank, bank power systems, etc. In this representation, if I have made any mistakes, I I sorry to all and thank you all the very best.